Speed 1 2 1 2. And now come on.
Speed 1 2 1 2.
Just talk normal. Alright, good night everyone and welcome to Moyo Math. This is Mr. Moyo. My apologies for the audio. But what I was saying previously, your ANMAT exam is on Wednesday. In that exam, there are going to be a number of repeated questions, yes. But what I want to do tonight is to have a short live and to ensure that we are clear on the steps with regards to many of these questions, right? So it shouldn't be a case where we are looking for, hoping that we see the question and hoping that it is a question we would have reviewed by looking at the answers and just to share that answer. We want to ensure that we can understand the steps just in case minor changes are made. We'll know the correct, relevant steps to help us to get it correct. Okay? So if you look at the history of the exam paper, there are going to be a number of repeated questions, but we want to make sure that our understanding is there, full grasp and understanding. So I'll be going through a past paper question tonight, starting with June 2022, the most recent, going through giving full explanations, proper, thorough explanations to the questions. And tomorrow I'm going to do another live. Tomorrow I may do probably about 2, if not 3 past papers. So we can at least do a number of past papers and we are guaranteed to see repeated questions. It is guaranteed, but let's make sure if minor changes are made, we will know what steps we can implement to help us to get the correct answer. Alright? So tonight will be a short live and we're going to start with this paper here, questions from this paper. This is from June 2022 exam paper. So it says here, question 1, the expression x minus 2 is a factor of. So if you have to show that x minus 2, which is known as a linear factor, if it is a factor of the expression shown, we know if this linear factor is a factor of any of these expressions if the remainder is 0. So for us to do so and show that the remainder is 0, we're going to start by stating let x minus 2 be equal to 0 and therefore x is equal to positive 2. And what we're going to do, we want to determine which one of these functions, when I substitute 2 into that function, will give me 0. And once we obtain 0, then clearly it is a factor of that function. So let's try a. So a, if I substitute, I'm going to put f of 2, if I consider 4x to the power of 4 minus 2x squared minus 56 to be f of x, then this will be f of 2 will be equal to 4. I'm going to replace x with 2 to the power of 4 minus 2 times 2 to the power of 2 minus 56. So 2 to the power of 4 will give us, this is 4 times 16 minus 2 times 2 squared will give us 4 minus 56. 4 by 16 will give us 64, and negative 2 by 4 of course is negative 8 minus 56. 64 minus 8 will give us 56, and 56 minus 56 is 0. So certainly x minus 2 is a factor of a, since when we substitute 2 into the function we got 0. So let's move on now to question 2. Making sure we're clear on the steps. So question 2. One over x plus 3 plus 3 over x squared minus 9 expressed as a single fraction is. So for question 2, we have 1 over x plus 3 plus 3 over x squared minus 9. So we want to determine or represent this expression as a single fraction. So to represent this as a single fraction, what are we going to do? First, when you are given fractions, whether it is basic fractions or fractions in algebraic form, once you're adding or subtracting fractions, the first thing you have to do is find the LCM. So we are going to rewrite this as 1 over x plus 3 plus 3 all over. Now x squared minus 9, we can factorize this expression by using the method of the difference of two perfect squares. X squared is a perfect square. We can represent it as a product of the same two factors. 9 is a perfect square. We can represent it as a product of the same two factors. And when we factorize it, we're going to get x plus 3, x minus 3 as our factors of the expression shown. It's factorized. So what we want to do is find the LCM. We're adding these two fractions. We're going to find the LCM. The LCM will be 1 of each term. If we look at our denominator, we're seeing x plus 3 and we're also seeing x minus 3. So our LCM will be 1 of each. X plus 3, x minus 3. And what I'm going to do is carry out my normal process of treating with fractions. I divide my denominator into the LCM. So x plus 3 into my LCM. My two x plus 3's will divide into each other to give me 1. I'm going to be left with x minus 3. And I'm going to multiply x minus 3 by 1 to give me x minus 3, plus I'm going to take my denominator and I'm going to divide it into my LCM. X plus 3, x minus 3 into the LCM obviously will be 1, and I'm going to multiply 1 by 3. So 1 by 3 gives me 3. And of course I am going to simplify. So when I simplify, this becomes my negative 3 and positive 3 will obviously become 0. So I'm going to be left with x all over x plus 3, x minus 3. And if I look at my options, I'm not seeing this, but what I can do to obtain one of the options is to simply expand the denominator. So to expand x by x, x by negative 3, plus 3 by x, plus 3 by negative 3. X by x will give me x squared. X by negative 3 is negative 3x. Plus 3 by x is plus 3x. And plus 3 by negative 3 is negative 9, which will leave me with x all over negative 3x, and positive 3x will cancel out. So I'm going to have x all over x squared minus 9 as my final answer, whose answer here is B. So let's make sure that we understand the steps and we can carry out the correct procedure to help us to get the answer. So we don't want if changes are made and we're not sure as to what to do. Right? So we want to depend on answers. Let's make sure we understand how to work them out. Okay? So let's move on now to question 3. So question 3, which of the following graphs represents f of x is equal to x into 2 plus x? So we want to recognize which of the following graphs will represent that function shown. So that function is f of x is equal to x into 2 plus x. So if we were to expand by removing brackets, x by 2 will give us 2x and x by x will give us x squared. We will clearly recognize that this function here is a quadratic function. If I'm to expand, I'm going to get 2x plus x squared. F of x is equal to that. So this is a quadratic function. So I must sketch of it will be a parabola. Yeah? Now, because the number in front of x squared is positive, I know when I sketch my function, I expect to get a curve that is concave up. Alright? But in order for me to sketch a function, what is important, I need your roots. Your roots are very important. The roots are where the curve cuts on the x-axis. Alright? And that's all. Well, of course, we need the y-intercept, we need the turning points, but that is not necessary here. All we need are the roots. Okay? Now, already we know our curve will be concave up. But what are the roots? Where will that curve cut on the x-axis? So to determine the roots, this is what we do. We're going to take the function x into 2 plus x. We're going to let x into 2 plus x be equal to 0. Remember, it's a quadratic equation now, and you know to solve a quadratic equation, we can solve for roots. So if we let x into 2 plus x be equal to 0, we can see now either x will be equal to 0, so that is one root. So you know that your curve will cut the x-axis at 0, or 2 plus x is equal to 0, and therefore x is equal to, and minus 2 from both sides, x is equal to negative 2. So when I sketch, what am I looking at? I am looking at my roots being negative 2 and 0, and my curve will be concave up, whose answer is D. So question 3D. Let's move on to question 4. So question 4 states, if x squared minus 6x plus 13 is equal to a into x plus h all squared plus k, then what is a, h, and k? Of course, this is completion of squares. So for question 4, if we have x squared minus 6x plus 13, and we want it in that form, a into x plus h all squared plus k. Of course, I'm going to use the formula approach to help us to find a, h, and k. Already we know, in using the formula approach, we need to identify what is a first, which is the number in front of x squared, which is 1, b, which is the number in front of x, which is negative 6, and c, which is a constant, which is 13. So to find h, we know h is found by using b over 2a. I'm going to replace b with negative 6 all over 2 times a, I replace a with 1. So you're going to get negative 6 over 2. So already we know h will be negative 3. So a is 1, h is negative 3, and to find k, we're going to use the formula 4ac minus b squared over 4a. So I'm going to replace a, this is 4 times a with 1, I'm going to replace c with 13 in brackets, minus b squared, so I'm going to put negative 6 in brackets all squared all over 4 times I replace a with 1. So this becomes 4 by 1 is 4, and 4 by 13 will give us 52. Subtract negative 6 all squared will be 36 all over 4. And we're going to get here 36 from 52 will give us, that will give us 16. Yeah? And 16 over 4 will give us 4. So we know that the value of k is 4. So if we look to match what the option will be, a clearly will be 1, h will be negative 3, and k will be equal to 4. So for question 4, the answer there is E. Alright? Let's move on now to question 5. So question 5. So question 5. The number of visas v to the power of x issued by an embassy annually is given by that quadratic function. The least number of visas issued in a particular year is. So we have to determine the least number of visas. So we have for question 5. V of x is equal to 7x squared minus 42x plus 72. Now, for us to determine the least number of visas, we can use completion of squares to help us determine what's the least number of visas. So, if I complete the square, I have it in the form a into x plus h all squared plus k. The least number, which is normally the y coordinate, if you have here a curve, for example, a curve will have a turning point, And if I have to determine what is the least value or the lowest value, that lowest value, if I'm to draw a horizontal line intersecting the y-axis, this here will be the lowest value, right? Which is the least value. And the y coordinate of your turning point, this is the x coordinate of the turning point, that's the y coordinate of the turning point, that represents the least value, and it is also represented by k. Alright? So all we need to do is find the value of k, and once we find the value of k, then we can determine what is the least number of visas issued in a particular year. So how are we going to find k? Again, we know we have this quadratic function. Let us make sure we can recognize what is a. So let me rewrite it. So I know that a is equal to 7, b is equal to negative 42, and c is equal to 72. And I know h is represented by 4ac minus b squared over 4a. So all I'm going to do is to substitute into that and work it out. And once I determine what is k, right? K is equal to 4ac minus b squared over 4a. And once I work out what is k, then that will help me to determine what is the least number of visas issued. So this will be what? 4 times. I'm going to replace a with 7. I'm going to replace c with 72 minus, this will be negative 42 in brackets all squared over 4 times 7. So this becomes, I'll just quickly use my calculator to work it out. This is 4 times 7 times 72, yeah? Which will give us 2016. Subtract, this is negative 42 all squared, which will give me 1764 divided by 28. So when I subtract 2016, subtract 1764, that will give me 252. And when I divide 252 by 28, I'm going to get 9 as my answer. So for question 5, the answer is B. So when I ask you for the least number, basically what you're doing with this expression is quadratic. You complete the square and you're using k, which represents the y coordinate of the turning point, or the least value. Of course, representing the least number of visas issued in this case. Alright, so let's move on to question 6. So question 6. Right, so the roots of the equation for question 6. We have 5x squared plus 6x minus 2 is equal to 0. Now, we want to determine the roots of that equation. So, your roots can either be real roots, real and equal roots, or we can have imaginary roots. Yeah? Now, to help us to determine what type of root, we're going to use what we call the discriminant. And the discriminant, of course, is D. I'll use my discriminant as D, and I'm going to use B squared minus 4AC. Yeah? And what I need to do is recognize what is A first. A clearly will be the number in front of x squared, which is 5. B is the number in front of x, which is 6. And C is the constant, which is negative 2. So let me substitute into my discriminant. Let's call it discriminant. D is equal to B, which is 6 in brackets squared minus 4 times A, which is 5 in brackets, and C, which is negative 2. Good? So my discriminant here will be equal to 6 squared, which is 36, This is negative 4 by 5 is negative 20, and negative 20 by negative 2 will give me positive 40. So the discriminant is equal to 76. And clearly 76 is greater than 0. My discriminant D is greater than 0. I can state B squared minus 4AC is greater than 0. And if B squared minus 4AC is greater than 0, it indicates that our roots are real. But this is a quadratic equation, yeah? And if we have to solve this quadratic equation, you can try it on your own, solve this quadratic equation, we're going to get two different roots, yeah? And once we get two different roots, it will indicate that those roots are distinct. So the roots are real because the discriminant is greater than 0, and if we solve the quadratic equation, we're going to get two different roots, which will indicate the roots are real and distinct. Alright? So for question 6, the answer there will be B. So let's move on now to question 7. So question 7. The values of x of which 3x minus 2 over 2x plus 1 is less than or equal to 0 are. So for question 7, we have 3x minus 2 all over 2x plus 1 is less than or equal to 0. So this here is a, what we call a rational inequality. So to solve this rational inequality, a rational is a fraction, and what we need to do is to remove it from the fractional form. So to do so, we can multiply both sides by the square of the denominator. So I'm going to multiply what is on the left by the denominator squared is less than or equal to, I'm going to multiply what is on the right, of course, by the denominator squared. So when I simplify this, I'm going to get what? 2x plus 1 into 2x plus 1 squared will give me 2x plus 1. And this will be 2x plus 1 times 3x minus 2 is less than or equal to 0 by 2x plus 1 squared is 0. Now what we have here is a quadratic inequality. And what we're not going to do is expand this, no. What we're going to do is to continue working with it as our product of factors. So we're going to jump into a quadratic equation by simply allowing, we're going to let 2x plus 1, 3x minus 2 be equal to 0. And this is important for us to obtain the roots. Because remember, this is a quadratic inequality we are solving now. This is a quadratic inequality. If you expand this, you're going to get a quadratic expression. You'll have your inequality symbol and 0, making it a quadratic inequality, a quadratic inequation. So we let the binomials be equal to 0. This will help us to get our roots. So we're going to simply state either 2x plus 1 is equal to 0, 2x is equal to negative 1, x is negative a half, that's one root, or 3x minus 2 is equal to 0, 3x is equal to 2, x is equal to 2/3. So I have my two roots. But because it is a quadratic inequality, we are solving for a range of values. So to get the range, we're going to use our sketch to help us to get the range. Alright, if you expand the two binomials, you're going to get a quadratic expression whose number in front of x squared is positive, which will indicate that when I'm sketching, my curve will be a curve that's concave up. It's going to meet the x-axis at negative a half, which will be on the left, because negative a half obviously is less than 2/3. And I'm going to put 2/3 on the right. So this is one root and this is the other root. So you recognize your two roots. And because it is less than or equal to, what we often do is to shade the roots. If it's less than or equal to or greater than or equal to, you shade the roots. And for us to determine where the range of values lie, this is important. The inequality symbol is a less than or equal to. So if it is a less than or equal to, it means the range of values that will satisfy this inequality lies below the x-axis. So below the x-axis. because it is less than or equal to, so we're looking at the region below the x-axis. If it's greater than or equal to, we look at the region above the x-axis. So the region below the x-axis, where our range of values will lie and will satisfy the inequality, it lies within this region here. Alright, I like to call that region the belly of the curve. So if it lies within this region, and we can take a test point, if you take a test point between -1/2 and 2/3, and you put it into this inequality, it's going to satisfy. If you replace x with that value and you work it out, you're going to see where it's less than or equal to 0, which means that anything in this region will satisfy the inequality. And this is our region we're focusing on. But to write it as a range of values, we can simply state here, x obviously will be greater than or equal to -1/2, and x will obviously be what? Less than or equal to 2/3. So x is greater than or equal to -1/2, and x is less than or equal to 2/3. And what we can do, anytime it falls within this region of the curve, we can collate it. Collate means we can bring them together. So to bring them together, what we do, we leave the x less than or equal to 2/3 as is. But if x is greater than or equal to -1/2, that also means -1/2 is less than or equal to x. Right? So this is us bringing the two inequalities together. So we leave x less than or equal to 2/3 as is. If x is greater than or equal to -1/2, it means -1/2 is less than or equal to x, whose well, in this case, we can use the answer as for question 7. This will be C. Yeah? So that will fall within the range. Yeah? So let's move on to question 8. So question 8. We have here the range of values of x for which 4x minus 3x squared is greater than 0. We want to determine the range of values of x. Good? So for us to determine the range of values of x, this here is a quadratic inequality, so we are clearly, when we solve this, we are solving for a range. Not so? So to do so, we need to get the roots first. The roots are very important. So to get the roots, we let 4x minus 3x squared be equal to 0. And what we can do is solve that quadratic equation by factorizing. I can pull out x. I divide x into 4x to give me 4. I divide x into -3x squared to give me -3x is equal to 0. And at this point, I can use the keywords either x is equal to 0, so that's one root, or 4 minus 3x is equal to 0, -3x is equal to -4, and therefore I can divide both sides by -3. X is equal to +4/3, which are my roots. But remember, it's an inequality. Quadratic inequality, so we have to find the range of values. So to find the range of values, what we're going to do is simply use our sketch to help us to find the range of values. Now, because this is a quadratic function whose number in front of x squared is negative, it means that our curve, if we are sketching, our curve will be concave down. So we're looking at this. Because the number in front of x squared for the quadratic expression is negative, right? And your roots in this case will be 0 and +4/3. Yeah? So this is one root, that's another root. And because it is greater than, where will our range of values lie? Greater than means we're looking at the region above the x-axis. And if it's above the x-axis, our range of values of x that will satisfy that inequality will lie within this region here. Yeah? So we can simply write this as our range of values of x. X will be greater than 0, And anytime it falls within this region, I like to call it the belly of the curve, we use the word and. X is obviously less than 4/3. And anytime it falls within that region, something you have to note, what you can do is correlate or bring them together, as we saw in the last question. So anytime it falls within that region of the curve, you can correlate it. How do we correlate it? I'm going to leave x less than 4/3 as is, leave what is on the right as is. And if x is greater than 0, it means 0 is less than x. And x is less than 4/3. Whose answer for question 8 will be C. So let's move on to question 9. So question 9, the expression the square root of 5 minus 1 over 1 plus the square root of 5 when simplified is equal to. So for question 9, we have the square root of 5 minus 1 over 1 plus the square root of 5. So what we have here are surds. Now, you never work with a surd in the denominator, so the aim is to remove the surd from the denominator. To do so, what we can do is rationalize. So we're going to rationalize the surd by multiplying this fraction by another fraction whose numerator and denominator is the conjugate of what is in the denominator of this fraction. And what is the conjugate? If you have 1 plus the square root of 5, the conjugate of that will be, just to change the sign, 1 subtract the square root of 5. That's the conjugate. See, that should be change the sign. Keep the two terms as is and change the sign. So for this fraction, I'm going to multiply the first fraction by, I'm going to put in the numerator the conjugate of what is in the denominator. Remember what is in the denominator? 1 minus the square root of 5. And I'm going to put also in the denominator the conjugate of what is in the denominator of your first fraction. Okay? And what we're going to do here is multiply these 2. So let's multiply our numerators and we multiply our denominators as well. So this will come the square root of 5 subtract 1 multiplied by 1 minus the square root of 5 all over 1 plus the square root of 5, 1 minus the square root of 5. And let me expand what is in my numerator. This is the square root of 5 by 1 and the square root of 5 by negative the square root of 5, negative 1 by 1 and negative 1 by negative the square root of 5. I'm going to do the same for my denominator, 1 by 1 by negative the square root of 5, negative the square root of 5 by 1 and negative the square root of, positive the square root of 5 by negative the square root of 5, right? So we're going to get what? The square root of 5 by 1 is the square root of 5. The square root of 5 by negative the square root of 5 becomes negative the square root of 25, which is 5. Negative 1 by 1 is negative 1. And negative 1 by negative the square root of 5 is positive the square root of 5. All over, let me expand, 1 by 1 is 1. 1 by negative the square root of 5 is negative the square root of 5. Positive the square root of 5 by 1 is positive the square root of 5. And positive the square root of 5 by negative the square root of 5 is negative the square root of 25, which becomes negative 5. So when I simplify this, what are we going to get? This becomes the square root of 5 plus the square root of 5 becomes 2 the square root of 5. And negative 5 subtract 1 will give me negative 6. All over, in the denominator, my 2 negative the square root of 5 and positive the square root of 5 will become 0. And 1 minus 5 will give me, negative 4. Yeah? And what can happen here now, in my numerator, I can factorize. So I can pull out here 2 as my common factor. But what I'm going to do, because I have positive a half and the positive a half and positive a third as my factor, I'm going to rearrange this. I'm going to write this as negative 6 plus 2 to the square root of 5 over negative 4. So when I factorize, it can help me to achieve what is in my options. Right? Because if I look to factorize and simplify, if you look at my options, all the factors are positive factors, not negative factors. So to help me to get positive factors, I'm going to rearrange this by writing it as negative 6 plus 2 to the square root of 5 over negative 4. And now let me factorize. So when I factorize the numerator, always remember the sign controlling the first term is automatically a part of the highest common factor. So you pull that out. And what else is common? So 2 is common, so I can pull out negative 2, which is my highest common factor. Let me divide negative 2 into negative 6, which gives me positive 3. And let me divide negative 2 into plus 2 to the square root of 5 will give me negative the square root of 5 all over negative 4. Alright? And what can happen here now, I can say negative, I can simplify further, I can divide negative 2 into negative 4. So I'm going to say negative 2 into itself is 1, and negative 2 into negative 4 will give me 2, positive 2. So my final answer, I can express it as a half into 3 minus the square root of 5. Good? Whose answer there for question 9 is D. Let's move on to question 10. So 10, we have the nth root of 3 times 27 to the power of m is equal to. Now, this is where our knowledge of indices will come into play. So this is the nth root, because the order of the root is n, and you can write this as 3 times 27 is the same as 3 cube all to the power of m, which becomes the nth root of 3 times 3 to the power of 3m. And what we can do is simplify this by applying our law of multiplication of indices. 3 has a power of 1, so I can write this as the nth root of 3 to the power of 1 plus 3m. And what I'm going to do is to apply my law of the fractional index, meaning if I have, for example, a to the power of m over n, anytime your index is a fraction, you can express it as, you can bring in the radical or the root symbol. A will go under the root symbol. The numerator of the fractional index becomes the power of a, and the denominator of the fractional index becomes the order of the root. Alright? So the same thing will happen here. We could do the vice versa. So you can move from here back to here. A stays as is, m becomes the numerator, n becomes the denominator. So you're going to do the same. This becomes 3. 1 plus 3m becomes the numerator, and the n becomes the denominator. So we're going to have here d as our answer. 1 plus 3m is the same as 3m plus 1, right? Over n. And we're going to have d as the answer. Alright, let's move on to question 11. So question 11. The value of 2 to the power of z, where z is equal to 5 plus log 3 to base 2. So we want to find the value of 2 to the power of z, where z is equal to 5 plus log 3 to base 2. So of course, this is a question that will require us to use our knowledge of logarithms, our laws of logarithms. So what we can do here with the laws of logarithms, when you have an equation in logarithmic form, the aim is to ensure that all terms are of the same base. This here is a base of 2. This right now is not a base of 2. Z is not a base of 2. You have to make sure all the terms, you have to get all the terms to a base of 2. So how can I represent Z as a base of 2? And this is where you have to know your laws, right? So one of the laws of logarithms is log A to base A, which is equal to 1. So that's an important law, right? So to express Z to a base of 2, you can write it as Z log 2 to base 2. To get 5 to a base of 2, you can write it as 5 log 2 to base 2. So log 2 to base 2 is 1, 1 by 5 is 5. Log 2 to base 2 is 1, 1 by Z is Z. Right? So you have the same thing, but now to a base of 2, right? Plus log 3 to base 2. And then you can apply now your laws of logarithms. So this Z now, the law of logarithms, which is the, what we call the power law, log of A to the power B to base C. You can put the B in front, log A to base C. So you do the vice versa. This Z comes up, so it becomes as a power log 2 to the power of Z to base Z is equal to, you do the same thing here. This 5 comes up as a power log 2 to the power of 5 to base 2 plus log 3 to base 2. Good? And then what we want to do is make sure we have single log functions of the same base on either side of the equal sign. So you have a single log function to base 2 here on the left, and let's get a single log function to base 2 on the right. How are we going to do that? It becomes log 2 to the power of Z to base 2. To get this as a single log function, well, I'm going to express 2 to the power of 5 as 32 first. Log 32 to base 2 plus log 3 to base 2. And what's going to happen here, we can express what is on the right here as a single log function. You see I have a single log function on the left. Let's get a single log function on the right by applying our law of multiplication of indices. Good? Which is known as the product law. So this becomes log 2 to the power of Z to base 2, and this is log, you're multiplying 32 by 3, which becomes 96. So you're going to get log 2 to the power of Z to base 2, log 96 to base 2. And once you have single log functions of the same base on either side of the equal sign, what you can do is equate with what you call the arguments. So call them arguments. This 2 to the power of Z and 96 are arguments. You can put them equal to each other. Right? So the value of 2 to the power of Z is really C96. So question 11, that answer is C. So let's look at question 12. So question 12, which of the following mathematical statements are true? So of course, this first one, it is highlighted the product law. We have the product of two functions, but the product law is not log phi to n multiplied. That has to be addition. This here is known as the quotient law. You're dividing, but this is right. Log p to base a minus log q to base a is right. And this here is the power law. So we're taking the power, you're going to put it in front of the log function. So you're going to get b log p to base a. So the answer here will be 2 and 3. So for question 12, that answer is C. Right, so question 12, the answer is 2 and 3. Right, which is C. Right, so but before I continue, class, just for everyone to know, on Saturday I'm going to have something very special for the preparation for the math exam on the 13th. Yeah, look out for it. All the information will be sent to, sent to my Instagram. It's going to be sent to the various links. It's going to be sent out. So look out for that information. Very important course to prepare you for that math exam. Everything is based on the multiple choice. So once you do that course, which is coming up Saturday, yeah, you are going to certainly pass and pass well. You can work towards getting full marks in that examination. So look out for that. For the information will be shared by tomorrow for the latest. The information will be shared, and I hope everyone can be a part of it. All right. So let's look at question 13. Don't forget to like and also subscribe to my channel. So question 13. We have here the sum of the first n terms of a series is given by that symbol. We have the summation symbol, which represents the sum, and of course representing the n terms, and we have r is equal to 1, and we have 5 minus 3 to the power 3r. So the sum of the first 10 terms, we want the sum of the first 10 terms. So to determine the sum of the first 10 terms, what we need to do, we have r equal to 1, we need to find what these 10 terms are. Alright? Now we are a bit tedious to write down what all 10 terms are, but what we can do is start by substituting 1. This is what the r equal to 1 will mean. When I substitute r equal to 1 into the function here, I'm going to identify what is the value of my first term. So my first term will be 5 minus 3 times 1 plus, remember it's a sum, so my second term I'm going to substitute 2. 5 minus 3 times 2. My third term will be 5 minus 3 times 3 plus dot 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 dot. So let me figure out let me work out what the first 3 terms are and have a sense as to what kind of series this is. Yeah? Whether it's an arithmetic series or a geometric series. So this will be what? 5, negative 3 by 1 is negative 3. 5 minus 3 will give me 2. This will be 5 minus negative 3 by 2 is negative 6. 5 minus 6 will give me negative 1. So this will be plus negative 1, which is negative 1. And this will be 5 minus 9. 5 minus 9 will give me what? Negative 4. Yeah? So, if we look here, if we subtract, and we can figure out the type of series. If I subtract 3 from 2, if I have negative 3, 2 minus 3 will give me negative 1. And if I subtract 3 from negative 1, negative 1 subtract 3 will give me what? Negative 4. Yeah? Which would indicate that this series here is an arithmetic series. This is an AP. Alright? And if it's an arithmetic series, then what we can do, the question asks us to find the sum of the first 10 terms. So instead of, no, you can't do this, so you can write down all the way to the 10th term and then add them up to get the sum. Yeah? Which will take some time, it's a multiple choice, right? But of course, many of these questions are repeated questions. If you see it, you shade one time. But let's make sure you know how to work it out just in case they bring something where you have to put some thought into it. So this will be what? You have here an arithmetic series. So for an arithmetic series, we know we must have a first term A, which is 2. We must have a common difference, D, which is negative 3. And they want us to find the sum to n terms. So n is equal to 10. So to find the sum to n terms, in this case 10 terms of an arithmetic series, remember we must know our formula. The formula is what? S is equal to n over 2 into 2a plus n minus 1d. So this becomes S is equal to 10 all over 2 into 2 times 2 plus 10 minus 1, which is 9, times d, which is negative 3. So this becomes S is equal to 2 into 10 is 5, 2 by 2 is 4, 9 by negative 3 is negative 27. This becomes S is equal to 5 times 4 minus 27 is negative 23. And 5 by negative 23, sum will be equal to negative 115. Yeah? Whose answer there for question 13 is B. Let's move on to question 14. So 14, right, the sum of the first n terms of a geometric series. So we have the sum of the first n terms of a geometric series is that, right? So for this series, we have the common ratio is negative 1. The first 3 terms are that, 3, 12, and 48. And the sum to 2, subscript 2n is equal to 2 to the power of 4n minus 1. So they want us to determine which of the following is right. Now we have here for question 14, we have here, so this here represents the sum of a geometric series. Good? Now n here, of course, normally n will represent, for example, what is sum of the given number of terms. So for our first term, if it's S subscript 1, the sum will be 4 to the power 1 minus 1, which is 3. So that's the first term, right? So the sum, that's the only term. So the sum obviously will be what? 3. Let's move on to 2. Our second term will be what? 4 to the power 2 minus 1. That is 60 minus 1, which is what? 15. Right? Now, looking at here to see which one, right, let's move on. Sum to 3. The third term will be what? 4 to the power 3 minus 1. 4 to the power 3 will be 64 minus 1, which is what? 63. So this is a sum of the first term obviously, so that will be your sum obviously. So the first term plus something, this is the sum of your second term, right? So the first of your 2 terms, right? First 2 terms, when I add them, this is the sum of my first 2 terms. So what number when added to 3 will give me 15? Because this 15 here represents the sum of my 2 terms, first 2 terms. So what number when added to 15, to the 3, sorry, will give me 15, and that has to be what? That has to be 12. So my first term obviously will be 3, and my second term obviously will be what? Will obviously be 12, because 3 plus 12 will give me 15. And similarly, my third term. So what number when added to my third term, or to my second term, sorry, can give me 63, to give me the sum of the 3 terms, first 3 terms. So obviously, if I add 48, right, 48 plus 15, that will give me what? 63. So therefore, I know that my first 3 terms is right. Yeah, that 3, 12, and 14 is right. So I know automatically 2 is right. Yeah? Let's see. Now, if this is a geometric progression, a geometric progression will have a common ratio. So your terms are 3, 12, and 48. Obviously, with 3, 12, and 48, my common ratio cannot be -1. So I know that 1 is automatically out. The common ratio can't be -1. And let's look at 3. Let's see if 3 is applicable. So 3, you have s to the power of n is equal to 4 to the power of n minus 1. Alright? Now let's see if we can use this to achieve this. So if you have s to the power of n is equal to 4 to the power of n minus 1, This is s to the power of n is equal to 2 to the power of 2n minus 1. Yeah? So 4 is the same as 2 squared, and when you multiply the two powers, 2 by n will give you 2n. So if this is s to the power of n and I've rewritten it as such, then s to the power of 2n means where I'm seeing n, I'm just replacing it with 2n. So this becomes 2 to the power of 2 times 2n subtract 1, which can be written as what? S to the power of 2n is equal to 2 to the power of 4n subtract 1. Yeah? So we can move from here to here. So it means that 3 is right. 3 will satisfy it as well. Okay? So the 2 that satisfies the geometric series, the sum of a geometric series given there initially, will be 2 and 3, whose answer is C. Yeah? So that's question 14. Let's move on now to question 15. So let me erase. So 15, a sequence of positive integers u is defined by that. So we have a sequence, the 10th term of the sequence is given by, so a sequence of positive integers, you have a sequence of positive integers, u to the power of n is defined by that. Okay? So the 10th term of the sequence is, so normally we use the function given Normally we use a function given to help us to determine the value of a given term. So if it's the first term, we substitute, we replace n with 1, we can work out as the first term. If it's the second term, we replace n with 2 and we work it out and so on and so forth. They want us to determine what's the value of the 10th term. So what's the value of the 10th term? So the 10th term, just replace n with 10, so you're going to get what? 3 to the power of a half, 10 minus 1, 3 to the power of a half, all to the power of 9, a half to the power of 9 will be what? This is 1, right? So a half all to the power of 9, that's all, that's, so this is all to the power of 9. That will give us 1 and 5 over 12. Good? So what is 3 multiplied by 1 over 5, 12? This will give us 3 over 5, 12. Whose answer for question 15, the value of the 10th term will be B. Yeah? So let's move on to question 16. It says here, the line 7x minus 4y plus 25 equal to 0 and 3x minus 4y minus 5 equal to 0 intersect at the point P. The coordinates of P are. So if we have two lines and they intersect at a point, which is P, they want us to determine what are the coordinates. All we have to do is basically solve them simultaneously. So we're going to write here 7x minus 4y, I'm going to take that positive 25 and put it over on the right as a negative 25, and you're going to have 3x minus y, negative 5 comes across as positive 5. What I'm going to do is just to solve using the elimination method. So this is 1, 2, so I'm going to multiply equation 1, I'm going to make both numbers in front of x 21, so multiply equation 1 by 3, equation 2 by 7. So you're going to get here 21x minus 12y is equal to negative 75. That's equation 3. And 21x minus 7y is equal to 35, equation 4. Now let me eliminate x by subtracting. So I'm going to put my subtraction sign. I like to put my subtraction sign in between. I'm going to draw my line. I'm going to say 21x subtract 21x is 0. Just as I have it here vertically, I'm going to write it horizontally. Negative 12y subtract negative 7y in brackets is equal to negative 75 subtract 35. So you're going to get negative 12y plus 7y is equal to negative 75 subtract 35, which will give us negative 110. And therefore negative 12y plus 7y is negative 5y is equal to negative 110, and y is equal to negative 110 over negative 5, which will give me positive 22. So the value of y is 22, so automatically that's the only option with 22, right? But let's make sure that x is 9, so I'm going to substitute y equal to 22 into equation, I'll put it into equation 2. I'm going to get 3x minus y is equal to 5. 3x minus 22 is equal to 5. 3x is equal to 5 plus 22. 3x is equal to 27, and x is equal to 27 over 3. X is equal to 9. So obviously for question 16, x is 9, y is 22. The answer there is C. Alright, let's move on to question 17. Well, let me erase. So 17 states the coordinates of the center of a circle with equation. So of course we have the equation of a circle, 17. We have x minus 1 all squared plus y plus 3 all squared is equal to 36. So we want to determine the coordinates of the center. So to determine the coordinates of the center, what I'm going to use is the standard form for the equation of a circle, and that is x minus h in brackets all squared plus y minus k in brackets all squared is equal to r squared. And once I know what are h and k, then I can clearly identify what are the coordinates of the center. But it must coincide with the equation given. So what I have to do is to rewrite this equation as x minus 1 squared. So of course the 1 here represents h, plus y positive 3, I'm going to write it as minus 3 in brackets squared is equal to 36. So you see I have it in the form, standard form of the equation of a circle, and what I can do now is clearly recognize what is h. H in this case will be 1, because we know the equation of a circle must have a center with coordinates h and k and a radius. Some people may use the coordinates of the center as negative h, negative k. Of course the format of the equation, the setup will be a bit different. But if you're using positive h, positive k, you can use this as your standard form, standard equation. So I can simply say here now that h will be equal to 1 and k will be negative 3. So the coordinates of the center will be 1, negative 3. Whose answer for question 17 is C. Alright, let's move on to question 18. So 18, right, so the points of intersection of the line with the equation of the circle is given. So we have a circle, that's the equation of the circle, which is x squared plus y squared is equal to 10. And we have this line which will obviously intersect the circle. And when it intersects the circle, it's going to intersect the circle at 2 points. So you know when you have a line and it intersects the curve at 2 points, you have to solve them simultaneously to find the coordinates of the point of intersection, right? So you have the equation of the circle, x squared plus y squared is equal to 10. You have the equation of the line as y minus x minus 2 is equal to 0. So I'm going to solve them simultaneously. So I have 1, I have 2. So from 2, I'm going to make y the subject. From 2, make y the subject. So this will be y is equal to x plus 2. I'll call that equation 3. Negative x comes across as positive x, negative 2, positive 2. And I'm going to substitute this now into equation 1. So substitute 3 into 1. So we're going to get what? This becomes x squared plus, I'm replacing y with x plus 2. In brackets, squared is equal to 10. Let me expand x plus 2 squared. That's x squared plus x plus 2 by x plus 2 is equal to 10. Let me expand it out. Let's see what we're going to get. This becomes x squared plus x by x by plus 2 by x plus 2 by plus 2. So we're going to get x squared plus 2x plus 2x plus 4 is equal to 10. And therefore, x squared plus x squared will give me 2x squared. 2x plus 2x will give me 4x plus 4 is equal to 10. So what we have here is a quadratic equation which we're going to solve. So this becomes 2x squared plus 4x, and positive 10 I'll bring across to the left as negative 10. So it's going to be plus 4 minus 10 is equal to 0. So we have 2x squared plus 4x minus 6 is equal to 0. And we can simplify that quadratic equation by dividing by 2. I'm going to get x squared plus 2x minus 3 is equal to 0. Let me solve that quadratic equation. Let me factorize. 1 by negative 3 will give me negative 3. And I want two factors of negative 3 that will help me to get the middle term plus 2x. So I'm going to use 3 by 1. So this will be 3x minus x. So of course it's going to be positive 3x minus, minus 1. When multiplied, can help me to get my middle term. Alright, so 3 by negative 1 gives out negative 3, but 3x minus x will help me to get this middle term 2x. So I'm going to write x squared plus 3x minus x minus 3 is equal to 0. I pair up, I pull out x as my common factor, I get x plus 3. I take out the sign that controls the first term of the second pair. Nothing is common here, but 1 is understood after that negative sign. Negative 1 into negative x is x. Negative 1 into negative 3 is positive 3 is equal to 0. So I can now further factorize to get x plus 3x minus 1 is equal to 0. And I can say either x plus 3 is equal to 0, x is negative 3, or x minus 1 is equal to 0, x is 1. And after I've found my two values of x, I need to get my corresponding values of y, and that can be easily obtained by substituting each value of x into equation 3 to find y, right? So substitute x equal to negative 3 into equation 3. We're going to get what? Y is equal to, replace x with negative 3 plus 2, y is negative 1. So 1 point will be negative 3, negative 1. I'm going to substitute x is equal to 1 into equation 3, and we're going to get y is equal to, I'm replacing x with 1 now, 1 plus 2, y is equal to 3. So my second point will be 1, 3. So my 2 points I am looking at will be negative 3, negative 1, and 1, 3, whose answer is D. Alright, so remember the objective of the exercise is to ensure that we know how to work it out. And of course, you may see these questions in the exam and you know it's an automatic circling of the answer. Share the answer one time, you know what it is. Let's make sure that we know how to work it out, have a sense of how we get the answer, alright? So let's move on to question 19. So 19, Right, so the vectors, look at 19. The vectors I and j represent 1 kilometer per hour east and 1 kilometer per hour north respectively. A man sails a boat on a lake such that the velocity is negative I plus 2j when there is no current. So when there is no current, that's the velocity represented by that. And if the current of 3I is encountered, so encounter a current of 3I, then the resulting vector V is. So this is a vector question. So we have the vector negative I plus 2j. Alright, so a man in a sail, he sails on a boat on a lake such that the velocity is that, right? And there's no current. So if this is a vector quantity, let's make sure we show this vector quantity on a grid. We can represent this, this is a position vector, more or less. We can represent this, the magnitude of this vector in terms of a column vector. So I'm going to take negative 1 and 2. I can represent my vector as such. And let me show that vector on a Cartesian plane, so I can actually see the movement of the vector and I can see how the boat is sailing. Right? So I'm going to have here 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, 1, 2, 3, 4 above the roof. So if it's negative 1, 2, what negative 1, 2 is not a point you're going to plot. Negative 1, 2 means you're moving 1 to the left because it's negative and 2 upwards. So this here is a position vector, so it will start from the origin. So this is the boat sailing that way, right? But then, and of course if it's a vector will have what? Must have direction. Alright? So let me put my 1 here. So it must have a direction, which is the arrow, and the magnitude is negative 1, 2. But then it says what? That this boat encounters a current. So this is the boat here sailing this way. So probably sail from a harbor, reach here, and then it encounters what? A current. The current is what? 3I. So of course, these are the magnitudes of the vector which can be represented in terms of unit vectors I and j. So 3I, you can represent it as 3I plus, there's no j, so it's really 0j. So you can write it as 30. Good? And what 30 means? 30 means that you're going to move 3 places to the what? Right. There's no vertical movement, only horizontal movement. So let me move 3 to the right. 1, 2, 3. Alright, so that's a movement of your vector. So I'm moving this way. So the boat experiences a current, and this is the direction when the boat experiences that current. So whose vector is 3I? The same as 3I plus 0j. It can be represented as 30. So let me put it in red. Let me put this in red too. So they want us to determine now what is the resulting vector, right? What is the resulting velocity or the resultant vector? So this will be the resultant vector here. Okay? So moving from O in that direction, that's a resultant vector. So to find the resultant vector, what you can do is use the triangle law to help you to find this vector here. So what's the triangle law? The triangle law is just to see which two vectors follow each other, which two vectors move in the same direction. If you want to call here O, you want to call here A, you want to call that B. You can say what? OA follows AB, and when two vectors follow each other, you add them. So you're going to put vector OA plus vector AB. They both move in the same direction. When you implement the triangle law, you recognize the two inner letters are always the same, and you connect the outer in that order. So OA plus AB will give you OB. And therefore, once you have created this equation based on the triangle law, then vector AB, you want to find vector OB, right? So you want to find vector AB. So vector OB is what you want to find, yeah? Is equal to vector OA, which is negative 1, 2, plus vector AB, which is what? 30, is equal to vector OB. So So when you work that out, what you're going to get? Negative 1 plus 3, 2 plus 0 is equal to vector OB. Negative 1 plus 3 is what? 2. 2 plus 0 is 2. So you're going to get vector OB as 2, 2. Which you can now rewrite as, back in terms of I and j, you can write it as what? 2i plus 2j. So vector OB is 2i plus 2j. Whose answer is question 19 as E. Right, let's move on now to question 20. Well, let me erase the board first. So question 20, the vector A is given as 5i plus 12j. A unit vector parallel to A is, so if you want to determine a unit vector parallel to A in a given direction, that direction of A, the unit vector of A, we have A, whose magnitude is 5i plus 12j, the unit vector of A, that little symbol on top, it showing it's a unit vector, is a fraction of the given vector. That's a unit vector. It's a fraction of the given vector whose magnitude is 1. The fraction is represented as 1 all over the modulus of A. That's a fraction. And we're going to multiply this fraction by the vector E. So what will be the modulus of A? 1 all over the modulus is the square root of x squared plus y squared times the vector A, which is this 5i plus 12j. Let's get the modulus, which represents the magnitude of the vector, the actual size of the vector quantity. This will be 1 all over the square root of x is 5, so that's 5 in brackets squared. Y is 12, so that's 12 in brackets squared, times 5i plus 12j. This becomes 1 all over the square root of 25 plus 144 times 5i plus 12j. That is 1 all over the square root of 169 times 5i plus 12j. Now because the square root of 69 is 169, sorry, is 13. So you're going to get what? This will become 1 all over 13 times 5i plus 12j. Whose answer is C. Yeah? So that answer there is C. So for question 20, the answer is C. Let's move on to question 21. So 21. Right, the position vectors of A and B relative to an origin O are 2, 5 and 3, negative 1 respectively. The acute angle AOB is, right? So of course, for 21, if you have to find the acute angle AOB, well, when it comes to vectors, I just like to set up a little diagram so you can have a visual of it. So you have here vector OA, you have 1, 2, 3, 4, 5. You have 1, 2, 3, 4. So vector OA, the magnitude is 2, 5, and OB is 3, negative 1. So OA means you're moving 2, 5, 2 to the right, 5 upwards. So 2 to the right because it's positive, 5 upwards because it's positive. So this is OA. So you have vector OE. Vector OB is 3, negative 1. Means you're moving 3 to the right because it's positive, negative 1 down, moving 1 down because it's what? Negative. Alright? So you have vector OB. So you have your two vectors, OA and OB. And what you want is the angle AOB, which is this angle here between them. Good? So So to find that angle, what you're going to introduce here is the dot product to help you to find the angle between the two vectors. So the dot product is what? Vector OA dot vector OB is equal to the modulus of OA dot the modulus of OB cos theta. OA is 2.5 dot OB is 3 negative 1 is equal to the modulus of OA, which is the square root of 2 squared x squared plus y squared, so that's 2 squared plus 5 squared, dot the modulus of OB, that is 3 squared plus negative 1 squared cos theta. So to work out what we have on the right and multiply those two, it's going to be 2 times 3 plus 5 times negative 1 is equal to, this will be the square root of 2 squared is 4, 4 plus 25 is 29, dot, this will be the square root of 3 squared is 9, negative 1 squared is 1, so that will be 9 plus 1 is 10 cos theta. 3 by 2 is 6, 5 by negative 1 is negative 5, so you have 6 minus 5 is equal to, apply surge, the square root of 29 by the square root of 10 is the square root of 290. Let's multiply the two numbers under the square root symbol to get the square root of 290 cos theta. So 6 minus 5 is 1, is the square root of 290 cos theta. And therefore to get cos theta by itself, we divided both sides by the square root of 290. So you're going to get 1 all over the square root of 290 is equal to cos theta, and therefore to get theta by itself, you will remove cos, which comes in front of that 1 over the square root of 90. Cos inverse of 1 all over the square root of 290 is equal to theta. Whose answer there for question 21 is E. Alright, let's move on to 22. So I'm erasing. So 22, which of the following graphs represents y equal to sine? It's a sine function. So with a sine function, you're going to have 0 is always defined between 1 and negative 1. You're going to have 0, you're going to have 90, you're going to have 180, you're going to have 270, and you're going to have 360. So your sine curve is always shaped like this. So you start at 0, you turn at 90, you cut the x-axis at 180, you turn at 270, and you end at 360. Yeah? So whose answer there for question 22 is D. Let's look at 24. So let me erase. 23, sorry. So let's look at 23. Right, what is the exact value of 23? Cos 5 pi all over 12. Now 5 pi over 12, now we have it in terms of 5 pi over 12. Now once it's cos 5 pi over 12, we can determine what is 5 pi over 12 in terms of a decimal number. That's 5. Pi in that case will be 180. 5 by 180 divided by 12, which is 75, right? So let us to get what we have there, this is the same as cos 75 degrees. So let's treat this as, so I represent it in terms of degrees, right? So let's treat this as cos, so I'm going to break it up into 2, I'm going to convert this into a compound angle. So it's going to be cos 45 degrees plus 30 degrees, okay? So I've represented my 75, which is a 5 pi over 12, as 45 degrees plus 30 degrees, representing a compound angle. And what I can introduce now is my compound angle formula. So I'm going to write this as cos, and remember what's the compound angle formula, right? Let me just make sure I write that. That's if you have cos A plus B, that is what? Cos A, cos B minus sine A, sine B. So remember that compound angle formula, right? So this becomes what? Cos 45 plus 30 will be cos 45 cos 30 minus sine 45 sine 30. Good? And remember, 45 degrees and 30 degrees are special angles, right? Special angles. So you know that cos 45 as a special angle, so make sure you know your special angles is the same as root 2 over 2. Cos 30 as a special angle is the same as root 3 over 2. Subtract sine 45 as a special angle is the same root 2 over 2 times sine 30 as a special angle is a half. So you're going to get here root 2 over 2 by this root 3 over 2 becomes root 6 all over 2 minus root 2 over 2 by a half becomes root 2. Sorry, this becomes root 2 over 4. Sorry, root 6 over 4. And this becomes root 2 all over 4. And therefore, what can happen? I can simplify this by factorizing. So I can put out a quarter. And when I divide a quarter into my first term, I'm going to get the square root of 6. And when I divide a quarter into negative the square root of 2 over 4, it gives me negative the square root of 2. Whose answer there for 23 is A. Alright, let's take a question 24. So 24. Right, so for 0 degrees less than or equal to x, which is less than or equal to 360, the equation 3 sine squared x equal to 8 cos x has only one real solution given by. So we have here for 24, so we have 3 sine squared x is equal to 8 cos x. Of course, this is a trig equation, and we want to find our solution for x within the range 0 is less than or equal to x less than 360. So if this is a trig equation, we can't solve a trig equation with two trig functions involved, right? Sine and cos. We have to get one trig function. So what we can do is convert, and you have to know your trig identities. We know that sine squared x is 1 minus cos squared x. Good? Sine squared x is equal to that. So let me replace this sine squared x with 1 minus cos squared x. I'm going to have my entire equation in terms of cos. So this becomes 3 into 1 minus cos squared x is equal to 8 cos x. And what I'm going to do here is remove my brackets. This becomes 3 minus 3 cos squared x is equal to 8 cos x. And what I will have here now, I'm going to bring my 8 cos x over to the left, so I'll have a quadratic equation. This becomes negative 3 cos squared x minus 8 cos x plus 3 is equal to 0. So I bring 8 cos x over as negative 8 cos x plus 3, of course, equal to 0. So what I have here is a quadratic equation. I'm going to remove the negative sign from in front of the term involving cos squared x. So when you have a quadratic equation, it's always good to work with a positive coefficient of the variable squared. So let me multiply by negative 1 to get 3 cos squared x plus 8 cos x minus 3 is equal to 0. But sometimes, we have a challenges to work with cos. So what you can do, instead of working with cos, you can let cos x be some variable, and then you bring it back into the question. So let me let cos x be equal to, say, m. So this becomes 3 m squared plus 8m minus 3 is equal to 0. And let me solve that quadratic equation to get my two values of m, and then I'm going to bring back cos into the question, alright? So I'm just doing this so it will make the quadratic equation solving it much easier. So 3 by negative 3 will give me negative 9, and I want two factors of negative 9 that can help me to get that middle term 8m. Of course, I'm going to use my 9 by 1, and this will be 9m minus 1m will give me 8m. So it's really 9m multiplied by negative 1, 9 multiplied by negative 1, sorry. So this will help me to get my 9m minus 1m, and therefore I'm going to get 3m squared plus 9m minus 1m or minus m minus 3 is equal to 0. I'm going to pair off, factorize the first pair, pull out 3m. I'm going to get m plus 3. I bring down my negative sign, nothing is common, 1 is understood. Negative 1 into negative m is m. Negative 1 into negative 3 is positive 3 is equal to 0. I can pull out m plus 3, and 3m minus 1 is equal to 0. So now what I'm going to do is bring back in cos into the mix. This becomes what? This becomes, so it becomes cos x plus 3 is equal to 0, right? Cos x is equal to negative 3. X is equal to cos inverse of negative 3. But cos is defined only between 1 and negative 1. And if you find cos inverse of negative 3, you're going to get no solution. So you know that result of the question tells us to get a value shown there, right? And then we have the other, which is what? 3 cos x, I'm replacing the m with cos. 3 cos x minus 1 is equal to 0. And this will certainly help us to get a value for x. It becomes 3 cos x minus 1 is equal to 0. Cos x is equal to 1. 3 cos x is equal to 1. And cos x is equal to 2. So this certainly will help us to get a real solution, one real solution. So whose answer there, because we didn't have to find x, just make sure we can get the function that can help us to find x, which is cos x equal to 2. And that answer there is B. So for question 24, the answer is B. So let's move on to 25. So 25, it says sine x plus 20 degrees is equal to cos x. Then the possible value of x is. So what we can do in this case, now this is a trig equation, yes, but instead of solving trig equation, what you can do is just easily use a method of trial and error to help you to figure out what's the answer. You can you want to make sure you can get both sides being equal. So what value of x will allow that to happen? You can simply replace x with one of the options. Let's go to 35 degrees. So the sine 35 degrees plus 20 degrees is equal to cos 35 degrees. This becomes sine 55 degrees is equal to cos 35 degrees. And when you work out sine 55 degrees will give us 0.189, 0.819. And let's work out what is cos 35 degrees. You got the same 0.819. So it means that the value of x that will satisfy the equation will be what? 35, because it allows both sides of the equal sign to be the same. So therefore your answer here will be A. If you substitute any of those, clearly we will not get the same thing on either side. Right? So for question 25E. So let's move on to 26. cos A plus B plus cos A minus B is equal to. So of course this will allow us to apply what we call our compound angle formula. So cos A plus B is the same as cos A cos B minus sin A sin B. So when you're using cos, always use the opposite sign, yeah? Plus cos A minus B will be cos A cos B plus sin A sin B. Yeah? And what's going to happen here? Clearly, negative sin A sin B and positive sin A sin B will cancel out. So you're going to be left with cos A cos B and cos A cos B, which are like terms 2 cos A cos B. Whose answer for question 26 is C. So let's look at 27. So 27. Right, so we have to prove this identity here. So we have sine x all over 1 minus cos x plus sine x all over 1 plus cos x. So first to treat with this, the first thing we're going to do is find the LCM. The LCM is 1 of each, which is 1 minus cos x, 1 plus cos x. So let me divide. 1 minus cos x into the LCM will give me 1 plus cos x, and I'm going to multiply sin x by 1 plus cos x. So this becomes sin x, and in brackets 1 plus cos x, plus, let me divide my denominator for the second fraction into the LCM. I'm going to get 1 minus cos x, and this is going to be sin x by 1 minus cos x. This becomes sin x into 1 minus cos x. Let me remove the brackets. This becomes sin x plus sin x cos x, and this will be plus sin x minus sin x cos x. All over, we have 1 minus cos x, 1 plus cos x. So let me simplify that. Clearly these two will cancel out in the numerator. So I'm going to get sin x plus sin x is 2 sin x. And when I expand this, the denominator, this becomes what? This becomes 1 by 1 is 1. 1 by plus cos x is plus cos x. Negative cos x by 1 is negative cos x. And negative cos x by plus cos x is negative cos squared x. So what's going to happen here? My 2 cos x in the denominator will cancel out. So I'm going to be left with 2 sin x over 1 minus cos squared x. And 1 minus cos squared x becomes 2 sin x. 1 minus cos squared x is the same as sin squared x. So you have to make sure you know your identities, right? And therefore, we know that this can be simplified. Sin x into sin x is 1, sin x into sin squared x is sin x. So I'm going to be left with my final answer 2 over sin x. Whose answer for question 27 is D. So 27D. Let's move on to 28. So 28, the figure MON below shows a quarter circle with radius 4 centimeters. The perimeter of the figure is, so if it's a quarter circle, it means that this angle here is 90 or pi over 2. Yeah? And of course the radius it is 4 centimeters. So for question 28, they want us to determine what is the perimeter of that sector. So the perimeter of that sector will be, so the perimeter P will be equal to OM plus ON plus the length of arc, which is MN. So what we need to do is to get the length of arc MN. So MN, the length of arc is formed by multiplying the angle is in radians, so we're going to multiply r by theta. So the radius of course is 4 and theta is pi over 2. So 4 by pi over 2 will give us 2 pi. So the length of MN is 2 pi. From here to here. Good? And of course, you want the perimeter. So perimeter is what? Perimeter is distance around. So the perimeter now will be 4 plus 4 plus 2 pi. That is 8 plus 2 pi. And what we can do, we can factorize. We can write P as pull out 2, 4 plus 5. Or we can write it as 2 into pi plus 4. Whose answer is D. So let's look at 29. So 29, they want us to determine what's the size of angle X. Of course, but it must be measured in radians. So let's get the angle X in degrees and then convert it into radians. So for 29, you know X will be equal to the sum of triangles of a triangle add up to 180. So that's 180 subtract 60 plus 100. That is 180 subtract 160, which is 20 degrees. So therefore, let's convert 20 degrees into radians. So we know the relationship between degrees and radians, which is 180 degrees is equal to pi radians. 1 degree is pi over 180, and 20 degrees is pi over 180 by 20. So you're going to get what? 20 into 180 is 9. So we end up with pi over 9 will be the size of the angle. Radians will be the size of angle X, right? In radians, so that's B. So for 29B, let's look at 30. So 30, right? So the one here for 30, the smallest positive angle in radians within the range 0 is less than theta less than 2 pi that satisfies the equation is. Good? So you want to determine what that is. So we have here this equation 2 cos theta minus 1 is equal to 0. So this becomes, so to solve this, So this becomes, just hold on, let me just charge my This one charge, charge. Big charge, one charge. Let's hold on, everyone. Alright, so let us continue. So we have 2 cos. Right, so we have 2 cos theta minus 1 times cos theta minus 2 is equal to 0. So we want to solve for the values of theta that satisfies the range between 0 and 2 pi. So we are going to simply, we're not going to expand this. What we're going to simply do is use either 2 cos theta minus 1 is equal to 0, 2 cos theta is equal to 1, cos theta is equal to half, and theta is equal to cos inverse of a half. And cos inverse of a half, if you want to convert your calculator into radians, or if you have it in degrees, and you want to find cos inverse of a half, which is 60 degrees, you can convert your 60 degrees into radians, yeah? So you can say 180 degrees is equal to pi radians, 1 degree is pi over 180, and therefore 60 degrees will be pi over 180 by 60, which will give us pi over 3. But if we look to use the other factor, so this is pi over 3, 60 degrees is pi over 3, which we have as our answer. And if we look to go with cos theta minus 2 is equal to 0, cos theta is equal to 2, theta is equal to cos inverse of 2. But remember, cos function is defined between 1 and negative 1. So cos inverse of 2 will be undefined. You put it into a calculator, you'll see it's undefined. So this answer here for question 30 will be pi over 3, whose answer is 8. So let's move on to 31. So 31, we have here, given that y is equal to the square root of 5 minus x, then what is dy over dx? 31. So if y is equal to the square root of 5 minus x, what is dy over dx equal to? So the square root of 5 minus x, we can write this as y is equal to 5 minus x all to the power of a half. And when we are differentiating dy over dx, we must begin with the differential coefficient. This function is a composite function. So when we're differentiating, we're going to multiply a half by 1, which is a half. We're going to keep the 5 minus x, which is within brackets. And we're going to subtract 1 from the power. A half minus 1 is negative a half. But remember, we have to multiply for the composite function. We use a chain rule. So we're going to multiply by the differential of what is inside the brackets, which is 5 minus x. So this becomes dy over dx is a half into 5 minus x all to the power of negative a half times the differential of 5 minus x. The differential of 5 is 0. The differential of negative x is negative 1. So we're going to get here negative 1 by a half. 5 minus x to the power of negative a half becomes dy over dx is negative a half into 5 minus x to the power of negative a half. But if you look, we don't have any of the options for what we've got here. None of those options reflect what we have here. So therefore, what we have to do is convert this negative index into a positive index. So we're going to write this as dy over dx. This is the same as negative a half times 5 minus x to the power of negative a half. If I move this from a negative index to a positive index, it becomes 1 all over 5 minus x to the power of positive a half. And when you have a power that's a fraction, you can convert that half back to the root symbol. So this becomes dy over dx will be negative 1 all over 2 times the square root of 5 minus x. Yeah? Whose answer is, for question 31, that answer is D. So for question 31, the answer is D. Let's move on to question 32. So 32, we have at a 10-meter stopping point on a runway, 32, an airplane is stationary before takeoff. So stationary means that it's at rest. If the plane travels 120 meters from this point in 4 seconds, what is the speed at the point of takeoff? So at the 10-meter stopping point on a runway, a plane is stationary before takeoff. So let's assume that this is the runway, this is our 10-meter stopping point, and the plane is what? Stationary before takeoff. If the plane, so it's been taken off, of course, the plane will have to travel 120 meters from this point, meaning it's going to be at 130 meters. This will make up with 120 meters here. In 4 seconds. So you made this run in 4 seconds. What is its speed at the point of takeoff? So the speed at the point of takeoff, you know, speed is equal to distance all over time. Distance is 120 meters. Time is 4 seconds. So when we divide 4 into 120, we're going to get 30 meters per second. Whose answer for question 32 is C. So question 32C. Let's move on to question 33. A curve C is given by the equation shown. The values of x at the stationary points occur are, the values of x at which stationary points occur are, so we know we have this function y is equal to 2x cubed minus 3x squared minus 12x plus 6. The values of x at which is stationary points of curves, now we know for stationary points, dy over dx is equal to 0. So what we need to do is to get dy over dx. So dy over dx will be to differentiate each term. This becomes 6x squared minus 6x minus 12. So I'm going to put that now equal to 0. So therefore 6x squared minus 6x minus 12 is equal to 0. And what I'm going to do is simplify this quadratic equation by dividing by 6. So I'm going to get x squared minus x minus 2 is equal to 0. And what I can do here now is factorize that quadratic, or solve the quadratic, factorize the quadratic expression, and solve the quadratic equation to get my two values of x. So this will be 1 by negative 2 is negative 2, and my two values of negative 2 that can help me to get my middle term would obviously be, that's going to be 2 by 1, that is going to be negative 2x plus x. So this becomes negative 2 multiplied by 1 will give me the negative 2x plus x, and therefore I'm going to get x squared minus 2x plus x minus 2 is equal to 0. I pair off. I'm going to pull out x as my common factor. So I'm going to get x minus 2. I bring down my plus sign. Nothing is common here. So I pull out 1. 1 is understood after my positive sign. I divide 1 into x to give me x. I divide 1 into negative 2 to give me negative 2 is equal to 0. And therefore I can now further factorize. We get x minus 2, x plus 1 is equal to 0, and I can say either x minus 2 is equal to 0, x is 2, or x plus 1 is equal to 0, x is negative 1. So my two values of x, so which is stationary points of curve, will be x as negative 1 and x as 2. So the answer for 33 is B. So let's move on to 34. The curve C has the equation y equal to f of x, and C has a stationary point, at negative 2, 5. If f double prime, which is the second derivative, is equal to x to the power of 4 minus 15, then the point, that stationary point, negative 2, 5 is. So once we have the second derivative as x to the power of 4 minus 15, we can use the second derivative to identify what is the nature of that point. So we're going to take the point, x coordinate of that point. So when x is negative 2, f double prime x becomes what? Negative 2 raised to the power of 4 minus 15. Negative 2 raised to the power of 4 will give me 16, yeah? And 16 minus 15 will give me 1, which will indicate that the second derivative is greater than 0. And if the second derivative is greater than 0, it will tell us that that point, negative 2, 5, is a minimum turning point. Whose answer for question 34 is C. Let's move on to 35. So 35 states, if f of x is equal to sine 3x minus cos x, then what is f double prime x? Again, second derivative. You see the double strokes? It means the second derivative. So f of x is equal to sine 3x minus cos 4x. So let's differentiate that. So it means that f prime x, which is the first derivative, we have to get the first derivative before the second, and this will be in differentiating sine of the angle 3x. The differential of sine the angle is always cos the angle, and we're using here the chain rule by the differential of the angle 3x. Subtract the differential of cos the angle is a negative sine of the angle by the differential of the angle. So we're going to get here f prime x will be, when I differentiate 3x, I'm going to get 3. So it becomes cos 3x times 3 minus, and this becomes the differential of 4x will be 4. So this becomes negative sine 4x times 4. So this becomes f prime x will be 3 cos 3x, and this will be a minus by minus is a plus. Of course, negative sine 4x by 4 becomes negative 4 sine 4x, but of course a minus by minus is a plus 4 sine 4x. So what we have here is the first derivative. But let's now get the second derivative. So I'm going to differentiate this again. So this will be 3 differential of cos the angle is minus sine the angle times, using the chain rule, the differential of the angle plus, I'm going to hold my 4, the differential of sine the angle will be cos the angle by the differential of the angle. And this becomes f double prime x will be differential of 3x is 3. So I'm going to get 3 times 3 multiplied by negative sine 3x becomes negative 3 sine 3x plus 4. The differential of 4x is 4. 4 multiplied by cos 4x becomes 4 cos 4x. And therefore, when I further simplify, f double prime x will be 3 multiplied by negative 3 sine 3x becomes negative 9 sine 3x, and 4 multiplied by 4 cos 4x will be 16 cos 4x, whose answer there is D for question 35. Let's move on to question 36. So 36. Given an expression for acceleration of a moving object, so you have the expression for acceleration, the velocity of the object can be formed by. Now, this will take us to a bit of kinematics. So you have S, which stands for displacement. V stands for velocity. A stands for acceleration. So, given an expression for acceleration, you have an expression for acceleration, the velocity of the moving object can be formed. So if I have to find velocity given acceleration, it means I'm moving this way. And if you have to find velocity given acceleration, it means you have to integrate the acceleration with respect to time. So you have to integrate the acceleration, and of course the acceleration will be your expression. So you're going to integrate the expression. So the answer to question 36 will be B. Let's look at question 37. So 37. If x is equal to the integral between the limits a and b, and f of x dx is equal to a, which is less than c, which is less than b, then what is x? Good? So we have x, which is the integral of that. Now let's assume that this is our function f of x, and f of x is defined between the limits a and b. So this is a and this is b. It also states that a is less than c and c is less than b. So let's assume that this is c here. A is less than c, c is less than b. So they want us to find the result of the integral of f of x between the limits a and b. So we can break this up into two parts, which will be the integral of f of x dx between the limits a and c, a being your lower limit, c being the upper limit, plus the integral between the limits c and b, c being the lower limit, b being the upper limit, f of x dx. So we would have taken the integral of f of x between the limits a and b, and we have represented it in that form, whose answer is C. Let's look at question 38. If C is a constant, then the integral of 2x minus 5 to the power of 3 dx is. So again, we're integrating a composite function here. So if we're integrating this composite function, what are we going to do? As soon as we begin integrating, integral symbol and dx will be dropped. So I add 1 to the power. So I add 1 to that power. I divide by the new power. But I must multiply by 1 all over the differential of what is inside of this bracket, and don't forget to add your constant c, because this is an indefinite integral, there are no limits. So this becomes 2x minus 5 to the power of 4 over 4 times 1 all over the differential of 2x minus 5 is 2 plus c, and therefore I can get 2x minus 5 to the power of 4 by 1 is 2x minus 5 to the power of 4. 4 by 2 will give me 8 plus c. And therefore my answer is 38 is C. So let's look at 39. If c is a constant, then the integral of sine x plus 2 cos x dx is. So 39. So we want to find the integral of sine x plus 2 cos x dx. So once we start integrating, the integral symbol and dx will be dropped immediately. So the integral of sine the angle is negative cos the angle. And remember to always multiply by 1 all over the differential of the angle. Plus the integral of 1 by 2. The integral of cos the angle is sine the angle multiplied by 1 all over the differential of the angle plus c. So the differential of x is 1, 1 over 1 is 1, 1 by negative cos x is negative cos x. Plus, the differential of x is 1, 1 over 1 is 1, 1 by sine x is sine x by 2 gives me 2 sine x, plus c. So I can rewrite this as, I can put 2 sine x in front, minus cos x plus c, whose answer for question 39 is A. So let's move on to question 40. The region R is enclosed by the x-axis, the curve y equal to negative x squared plus 2, and the lines x equal to 0 and x equal to 1. The area of the region R is. So we have here, let's assume that is our curve. Let's assume that's our curve. Y is equal to minus x squared plus, well, if it's negative, let me put it this way. Let's assume that that's our curve, right? Because in the number in front of x squared is negative. And it is y is equal to minus x squared plus 2. So they want us to find the region R enclosed by the x-axis. This is our x-axis here. The curve, this is your curve. Make sure I put my y-axis here. The curve and the lines x equal to 0. So x equal to 0 is that vertical line passing through the region, otherwise known as the y-axis. And the line x equal to 1. This is the line x equal to 1. So they want me to find the area of this region here. So to find the area of that region under the curve, with respect to the x-axis, my area is the integral between the limits a and b y dx. That's my formula for area. So this becomes a is equal to the integral between the limits 0 and 1. Y will be negative x squared plus 2 dx. So what I have to do now is to integrate that, substitute my limits. So this becomes a is equal to, drop the integral symbol and dx. So this becomes negative x cubed all over 3 plus, let me integrate 2, which becomes 2x. And of course I'm going to maintain my limits 0 and 1. Let me substitute my upper limit. This becomes a is equal to negative 1 in brackets cube over 3 plus 2 times 1. Subtract, I'll substitute the lower limit, which will give me 0 if I replace everything there with 0. I'll put 0 one time, because when you replace x with 0, you get 0 one time. And this becomes a is equal to 1 cube is 1, so I'm going to have negative a third plus 2, and negative a third plus 2 will give me 1 and 2 thirds, which is 5 over 3. So the answer there for 40 is 5 over 3, whose answer is B. So let's move on to question 41. So 41. So we have here a probability question. It says there are 108 cards in a deck of Uno playing cards. There are 4 wild, draw 4. There are 4 wild, draw 4, and 25 each of 4 colors, red, yellow, green, and blue. If a player needs to select one card, what's the probability of not drawing a wild card? Not drawing a wild card, right? So the probability of not drawing a wild card, while draw 4 card, right? Yeah? So the probability of not, while draw 4 card, not, I'm going to put my complement symbol, right? So once you talk about not drawing something or not something, with probability, what we have to do is to subtract the probability of drawing a wild draw 4 card from 1 in order for us to determine the probability of not drawing a wild draw 4 card. So this will be 1 minus the probability of drawing a wild draw 4 card. Alright, so the probability of not drawing a wild draw 4 card is equal to 1 minus the probability of drawing a wild draw 4 card. So what is the probability of drawing a wild draw 4 card? Yeah? So there are 108 cards in the deck. So there are 4 wild draw 4 cards, right? There are 4 of them. So there are 4 of them. The probability of drawing a wild draw 4 card is the number of ways it can happen. That's probability, which is 4 ways we can draw a wild draw 4 card all over the total number of possible ways, which is the total number of cards in this case, which is 108. So this is the probability of drawing a wild draw 4. So the probability of not drawing a wild draw 4 card will be 1 minus the probability of drawing a wild draw 4 card. So this is 108 over 108 minus 4 over 108, which becomes 104 over 108, and you can say 2 to the 10 is 5, 2 to the 4 is 2, 2 to the 10 is 5, 2 to the 8 is 4. I can still break it down. 2 to go into 5, 2. Remainder 1, 2 to 12, 6. 2 to go into 5, 2, 2 to go into 14, 7. So 26 all over 27, whose answer there is A. So let's look at question 42. So 42. So we have this box and whiskers plot here. So items 42 refers to the following diagram, which shows a box and whiskers plot of the height of male and female students in a physics class. You have male and female students, right? Which of the following values describe the range of heights? So what the overall range, right? The range of heights. And we know range means what? Highest value minus the lowest value. Good? So the highest value here, because we have both male and female students, and they want the range of the heights in the class, overall range, right? Which comprises of both boys and girls. So the overall range will be, the highest point will be here. And the lowest point will be what? Here. The highest point this corresponds to what? This is 170, 171, 72, 73, 74, right? So this is 171, 172, 173. And the lowest is obviously 155. So the range is the difference between the highest and the lowest value. So therefore this will be what? Range will be 173 minus 155, which will give us, that will give us 18, yeah? So the range is 18 for question 42, that answer for 42 is A. So 42 is A. So let's look at now question 43. So 43. Items 43 refers to the following table, which shows the performance of final year university students. majoring in social work or psychology on a research project. The probability expressed to 2 decimal places of selecting a student who failed is. So what is the probability of selecting a student who failed? We have students who pass, we have students who fail. The total number of students who pass will be 500 of them. And the total number of students who fail will be 40 of them. So they want us to express the 2 decimal, well, they want us to express the 2 decimal places of selecting a student who failed. So the probability of a student who failed will be the number of ways it can happen. So the probability of a student who failed, I'll put as subscript F, student who failed, is the number of ways in which it can happen, right? So that's 40 ways. We have 40 students who failed all over the total number of possible ways, which is the total number of students. We have 40 students who fail and 500 who pass. So the total number of students there will be what? 540. So when we break that down, we're going to get what? 0, 0, 0, go. 2 into 4 is 2, 2 into 54, 27. So we're going to get 2 over 27. And 2 over 27, let's see, because I have the answer expressed as a decimal. Let's see what is 2 over 27. Will give us, and they wanted to 2 decimal places, 1, 2, yes. So to 2 decimal places, we're going to get here 0.074. So to 2 decimal places become 1, 2. We look at the number after, which is 4. It's less than 5. So our 7 stays as is. So we're going to get 0.07. The 2 decimal places. So let's look at question 44. But both 44 and 45 relate to this Venn diagram. So items 44 and 45 refer to the following Venn diagram. There are 120 students in a school's music club. The Venn diagram shows the probabilities that a randomly selected student plays the piano, nor guitar, or all guitar, sir. So they want us to determine what is the value of X, which are those students who don't play. Right? So if the probability of those who play, they want us to find the value of X, right? So we have students who play the violin, and of course, and the guitar, right? And what we can do is, this can be done one of 2 ways, and it's good to know the probability formula for we're dealing with the union. Alright? So we know that the probability of students who play the piano or guitar, good, is equal to the probability of students who play the piano. So we're looking at here non-mutually exclusive events plus the probability of students who play the guitar minus the probability of students who play both the piano and the guitar. So the probability of students who play the guitar will be this entire circle here, which is 40, 0.4 plus 0.35, which will give us what? That will give us 0.75. The probability of students who play the guitar is the entire circle. That is 0.35 at 0.15, which will give us what? That will give us 0.5. Subtract the probability of students who play both the piano and the guitar is 0.35. So when we work this out, this will give us what? This will give us 0.75 at 0.5. That will give us 1.25 minus 0.35. So 1.25 minus 0.35 will give us what? So 1.25 minus 0.35 will give us 0.9. So that represents students who play the guitar or the piano. So we want to determine X, which are students who play neither the guitar nor the piano. So therefore, the probability who play neither the guitar nor the piano, which is X, will be to subtract 0.9 from 1. So 1 minus 0.9 and 0.9 from 1 will give us 0.1. Okay? Whose answer there is A, 44A. And we have 45. Right? So 45 we have now. We have what is the probability of a student to play the piano given the guitar. So remember what that line means, right? It means given. The probability of a student to play the piano given that they play the guitar. Good? So the probability of a student to play the piano given that they play the guitar. So we know that that is equal to the probability of the student to play the piano and the guitar over the probability of the student who plays the guitar. Good? So the probability of student to play the piano and the guitar is the intersection there is 0.35 over the probability of the student who play the guitar. That will give us 0.5 in the guitar, but that's 0.35 at 0.15. When you divide those two, 0.35 divided by 0.5 will give us 0.7. Whose answer there for question 45 is D. Right, so this will bring us to the end of this exercise. I hope it was beneficial to you. The purpose of the exercise is for us to go through thoroughly, ensuring that all the questions are well explained and we are clear on the steps required to achieve the result. So yes, when we enter that exam, we're going to be looking for the questions and the right answers, and once you see the right answer, you circle it. But again, sometimes they make minor changes, and once they make those changes and you are aware how to work it out, then clearly you can get the right answer. Right? So I hope everyone benefited from the exercise. Tomorrow I'm going to have another live, but keep in mind, just to note, I'm going to have a session on Saturday. This is for mathematics, something very special. The information will be sent out very soon, which is by tomorrow. All the information will be sent out, so look out for it. And I hope that we can be a part of that very important session to put you in a good position to get your distinction in mathematics. Alright? So with that said, everyone, have a great evening, and I'll see you all tomorrow. Take care.